Good morning, children. Today we will be starting a new lesson, Chapter 8, Quadrilaterals. Chapters 6 and 7 were dealing with triangles. So as a continuation of polygons, different polygons, let's proceed with Chapter 8, Quadrilaterals. If you review on triangle, any three non-collinear points in a plane, if they are joined by line segments, we get a triangle. That is, a polygon of three sides is called a triangle, or a rectilinear figure made up of three line segments will form a triangle. Imagine 4 points in a plane. If all the 4 points are collinear, we will be getting a straight line or a line segment. We will be getting a line segment. Suppose 3 points are collinear and the 4th point is non-collinear, then also we will be getting only triangle. So how do you form a four-sided figure or a four-sided polygon with 4 points given in a plane is, if all the 4 points take positions such that no 3 points are collinear, we get a four-sided figure, and we call that four-sided figure as a quadrilateral. That means the general definition of a quadrilateral is a rectilinear figure made up of 4 line segments, or a polygon having 4 sides. They all can be taken as a definition for a quadrilateral. That is, if a rectilinear figure is made up of only 4 line segments, then we can call it as a quadrilateral. If a polygon having 4 sides, they can be called as a quadrilateral. Consider the quadrilateral formed by joining the 4 points in this pattern. What do you observe here is, if you extend the first side, the remaining 2 vertices are on the same side of the line extended. Similarly, if you extend this side also, the remaining vertices are on the same side of the extended line. This happens for all the 4 sides of the quadrilateral, and hence these type of quadrilaterals are called convex quadrilateral. Whereas, if you take quadrilaterals, or if you take 4-sided figures in this particular format, if this side is extended, the remaining 2 vertices are on the same side of the line extended. Similarly, if you extend this line also, the remaining 2 vertices are on the same side of the line segment extended. But what about the extension done on this side? You can see one vertex is here and the other vertex is here. That is, both the vertices are on opposite side of the lines extended. Similarly, if you extend this line also, the remaining 2 vertices are on the opposite side of the line extended. Such quadrilaterals are called as concave quadrilaterals. But the study under your consideration is only about convex quadrilateral. That is, a polygon having 4 sides is called a quadrilateral, and you will be learning different kinds of quadrilaterals and the properties possessed by such quadrilaterals. let's discuss in detail how to name a quadrilateral or what are the elements or parts of a quadrilateral. Normally, we read the quadrilateral in a particular order. In the figure, A, B, C, D represents a quadrilateral. This quadrilateral has 4 sides. The sides are always line segments. So, what are the 4 sides? The sides are AB, BC, CD and DA. Normally, we take in an order the vertices or the points. What are the vertices? The vertices are always points and what are the vertices? The vertices are the points A, B, C, D. When 2 sides meet, a vertex is formed. What are at each vertex? There are angles formed and there are 4 angles for a quadrilateral. What are the angles of the quadrilateral is angle A, angle B, angle C and angle D. So in general, a quadrilateral has 4 sides and 4 angles. If you join the opposite vertices, you get a line segment. There are 2 line segments formed and by joining the opposite vertices, the line segment we are getting is named as the diagonal of a quadrilateral. Diagonal represents a line segment which joins the opposite vertices of any quadrilateral. What are the diagonals here? There are 2 diagonals. Diagonals are also line segments and they will be called as BD and AC. Kinds of quadrilaterals as follows. In the figure or in the representation shown here, ABCD represents a quadrilateral. Therefore, the definition of a quadrilateral, as we have already discussed, it's a polygon having 4 sides. And now, if any quadrilateral ABCD is in such a way that one pair of opposite sides are parallel, that means in the figure, AB is parallel to CD. One pair of opposite sides are parallel. It is called a trapezium. So the first definition is a quadrilateral in which only one pair of opposite sides parallel is called a trapezium. That means a trapezium is a quadrilateral in which only one pair of opposite sides are parallel. And now, if in a quadrilateral one pair of opposite sides are parallel and the other pair equal, in the figure AB is parallel to CD and the second pair AD and BC are equal in length, such a quadrilateral is named as an isosceles trapezium. So what is an isosceles trapezium? Is a quadrilateral in which one pair of opposite sides parallel and the other pair of opposite sides equal. Such a quadrilateral is named as an isosceles trapezium. And now a quadrilateral in which both pairs of opposite sides parallel is called a parallelogram. In this figure you can see the first pair AB is parallel to CD and the second pair AD is also parallel to BC. Such a quadrilateral is called as a parallelogram. So what is the definition of a parallelogram? a quadrilateral in which both pairs of opposite sides parallel is named as a parallelogram. And now this lesson deals with all the properties possessed by a parallelogram. Now the remaining kinds of quadrilaterals are all parallelograms with the properties based on angles or the sides. A parallelogram with one angle as 90 degree is called as a rectangle, because the property, the parallelogram shows that the pairs of opposite sides are parallel. By applying the property of parallel lines, we can calculate that all angles are 90 degree. Thus, a parallelogram with one angle 90 degree, a parallelogram with one angle as 90 degree is called as a rectangle. And now the second is a parallelogram in which all sides are equal. A parallelogram in which all sides are equal is named as a rhombus. A parallelogram with all sides equal is termed as a rhombus. And the next one is a parallelogram with all angles is called a square. A parallelogram with all angles also equal, all sides also equal is termed as a square. A parallelogram with all angles 90 degree and all sides equal in length is termed as a square. A parallelogram with one angle 90 degree is a rectangle. A parallelogram with all sides equal is a rhombus, and a parallelogram with all angles is 90 degree and all sides equal is called as a square. And now a special type of a quadrilateral called kite is when each pair of adjacent sides as equal. That means in the figure, a quadrilateral in which it need not be, all the four sides need not be equal. A quadrilateral in which pairs of adjacent sides equal in length. Equal in length is known as a kite. That means in the figure, AB and AD are in equal length and BC and CD are equal in length. These are the basic definitions of the different kinds of quadrilateral. We will be studying about the properties of these special types of parallelograms in detail. First, let's discuss about the properties possessed by the diagonals of each of these different kinds of quadrilateral. In any parallelogram, the diagonals AC and BD, they bisect. That means the diagonals AC and BD bisect each other. What is the meaning of that is O will be the midpoint of AC also, O will be the midpoint of BD also, that is the length of AO and OC will be equal. At the same time, length of BO and OD also will be equal. What is the speciality of the diagonals of a rectangle other than they bisect each other? Since a rectangle is also a parallelogram, the diagonals will definitely bisect, but what is the extra condition is the diagonals of a rectangle are equal. That means AC and BD are always equal in length, which shows that all the four parts AO, OC, BO and OD, all the four parts will be equal in length. That is, AO is equal to OC is equal to OB is equal to OD. And now, what is the speciality of the diagonals of a rhombus? The diagonals of a rhombus always bisect. At the same time, they bisect at right angles. The angle formed AOD, AOB, BOC and COD will be always 90 degree. The diagonals may not be equal in length, but AC and BD may not be equal, but the angle formed at the center is always 90 degree. That is, diagonals bisect at right angles. They always bisect at right angles. That is, angle AOD is equal to angle DOC is equal to angle COB equal to angle BOA is equal to 90 degree. And what is the property of diagonals of a square is the diagonals are equal also. Diagonals bisect at right angles also. It shows that in a square, the diagonals are equal as well as bisect at right angles. The length of AO, OC, BO, OD all are equal. At the same time, the angles are also always, they take 90 degree. So, in a parallelogram, diagonals bisect each other. In a rectangle, diagonals are always equal. In a rhombus, diagonals bisect at right angles. And in a square, diagonals bisect each other at right angles also. And the length of the diagonals are equal also. There are certain properties possessed by a parallelogram which can be derived by proving the first theorem in the lesson as Theorem 1. A diagonal of a parallelogram, divide it into two congruent triangles. That means you are given a parallelogram ABCD in which the first pair AB is parallel to CD and AD is parallel to BC. If you draw one of the diagonal, there are two triangles formed here, triangle ADC and triangle ABC. The theorem states that the two triangles will be congruent. That is, triangle ADC congruent to triangle ABC. So what is given is a parallelogram ABCD in which AB is parallel to CD and AD parallel to BC. And what is to prove? Triangle ABC congruent to triangle ABC congruent to triangle ADC. And now this theorem will be proved based on the properties of parallel lines. If AB parallel to CD and if AC serves as the diagonal, angle 1 is equal to angle 2, a pair of alternate interior angles. Similarly, for the lines AD and BC, the same AC as that transversal, angle 3 and angle 4 will form another pair of alternate interior angles. So let's present the proof as proof. In triangles ABC and ADC, angle 1 is equal to angle 2. We should specifically mention the parallel lines since AB parallel DC, alternate interior angles. The second pair, angle 3 is equal to angle 4 since AD parallel to BC, alternate interior angles, and which is the common side. The common side is AC is equal to AC common. Therefore, triangle ABC congruent to angle A is corresponding with angle D. So let's name it as triangle CDA by angle side angle. The triangles are congruent by ASA congruency. That is, the diagonal of the parallelogram divides it into two triangles which are congruent. What will be the corresponding parts here? Angle 1 and angle 2 are equal. Angle 3 and angle 4 are equal. Angle D and angle B are equal. So, as properties, again, AB and CD will be equal. AD and BC also will be equal. This all will be derived as the properties of a parallelogram, as opposite angles of a parallelogram are equal, opposite sides of a parallelogram are equal. After proving the triangles as congruent, let's write the corresponding parts. AB and CD are equal. AD and BC are equal. Similarly, angle B and angle D are equal. And we also got 1 equal to 2 and 3 equal to 4, which gives you the sum of 1 plus 3 equal to the sum of 2 plus 4, which gives you angle A and angle C are equal. All these will be the corresponding parts of the congruent triangles after proving triangle ABC congruent to triangle CDA. So what is the first property of a parallelogram? The first property of a parallelogram is opposite sides of a parallelogram are equal. Opposite angles of a parallelogram are equal. That is the second property. So what are the properties of a parallelogram? The first property is opposite sides of a parallelogram are equal. We proved it through the congruence of triangles. What will be the converse statement of it? If both pairs of opposite sides of any quadrilateral, if both pairs of opposite sides of a quadrilateral are equal, it is a parallelogram. The second property, opposite angles of a parallelogram are equal. What is the converse statement? If both pairs of opposite angles of a quadrilateral are equal, then it is a parallelogram. And the diagonals of a parallelogram bisect each other. This can be proved by an activity method. You can consider parallelograms with different length for the pairs of opposite sides which are parallel, and if you measure the length of the diagonals AO, OC, BO and OD, we can see that the diagonals bisect each other. That is, the length of AO and OC remains the same. Length of BO and OD also remains the same. So, if the diagonals of a parallelogram bisect each other, or what is the converse statement of it? If the diagonals of any quadrilateral bisect each other, it is a parallelogram. These are the three basic properties, and instead of considering both the pairs of opposite sides as parallel and equal, there is a very important property of parallelogram, that is, if the same pair of, very important property, if the same pair of opposite sides AB and CD are one pair of opposite sides, if AB is equal to CD and AB is parallel to CD, such a quadrilateral will also be a parallelogram. So what is a very important property is a quadrilateral in which one pair of opposite sides are parallel and equal, then it is a parallelogram. This is a very important property in quadrilateral, that is, if the same pair of opposite sides are parallel and equal, that quadrilateral is a parallelogram. So these are the properties we will be using in exercise 8.1.